Hello friends, welcome back. In this video session of refrigeration and air conditioning, my name is Mr. S.V. Kumbar, Assistant Professor, Sharad Institute of Technology, College of Engineering, Yadra, Ichakarchi. So today we are going to learn all air system which is related with air conditioning. Before that, quickly we will revise air conditioning. What is air conditioning? So generally, air conditioning is used to maintain humidity in all parts of building, free the air from excess humidity during certain season. It supplies a constant and adequate supply of ventilation. It effectively removes from the air microorganism, dust, soot and other foreign bodies and it cleans air effectively. It efficiently cools room air during certain season. It heats or help heat the room in winter. Now how an air conditioner works? For that purpose, generally if we have to use a compact vapor compression refrigeration system, and it consists of 4 different components. First one, compressor, second, condenser, third, expansion valve, and fourth, evaporator. In the compressor, vapors of refrigerants are compressed, due to which it is converted into high pressure, high temperature vapors of refrigerant. This high pressure, high temperature vapors of refrigerant are shown with the help of red dots. This high pressure, high temperature vapors of refrigerant is then passed through condenser, where a coolant is allowed to flow continuously over the condensing coil. So for that purpose, we can either use air or water. Now that cooling air carries heat energy from high pressure, high temperature vapors of refrigerant, and in the condenser, phase change takes place. It is converted into high pressure, low temperature liquid refrigerant. This high pressure, low temperature liquid refrigerant is temporarily stored in the liquid receiver, or it is passed through dryer. If any water vapor is present, it is dried, and only high pressure, low temperature liquid refrigerant is allowed to pass. When it flows through expansion valve, its pressure drops down suddenly, so that it is converted into low pressure, low temperature liquid refrigerant in the evaporator. At the same time, air is allowed to move over evaporative coil, where its humidity is maintained and cool air flows towards conditioned space. This is all about air conditioning system. When it flows through evaporative coil, it is again converted into low pressure vapors, and this low vapor pressure again compressed, and the cycle continues. So this is window air conditioner which is fitted. Half part of window air conditioner lies inside room and half part outside room. Cooling and dehumidification. Humidification means addition of moisture, dehumidification means removal of moisture. Generally, in most of the air conditioning system, cooling and dehumidification is achieved in summer season. So cooling is the most often achieved in an air conditioning system by passing the moist air over a cooling coil. This moisture will get condensed over coil. A coil is constructed of long serpentine pipe through which a cold liquid or gas flows continuously. The pipe is lined with fins to increase the heat transfer from air to the cold fluid in the pipe. The phase of the coil in the direction of airflow depends upon the coil design, required temperature drop, moisture level, moisture removal level, etc. So there are two results. The first, cooling coil cools the air as the air passes over the coil. Second, because the cooling fluid in the coil is usually well below saturation temperature. Moisture condenses on the coil and it drips off and it has to be drained away. This process reduces the enthalpy or heat of the air mixture and increases the enthalpy of chilled water or refrigerant. In another part of the system, this added heat must be removed from the chilled water or from refrigerant to be cooled for reuse the cooling coil. The amount of moisture that is removed depends on several factors, and that includes the temperature of cooling fluid, the depth of coil, whether the fins are flat or embossed, the air velocity across the coil, etc. The basic air conditioning system, which is today's important point, the majority of air is drawn from the space mixed with outside ventilation air and then conditioned before being blown back into the space. So as we have already discovered, in air conditioning system which are designed to meet variety of objectives like to maintain purity of air, to maintain humidity of air, and to maintain temperature of air. In many commercial and institutional systems, the ratio of outside ventilation air to return air typically varies from 15% to 25% of outside air. There are some systems which provide 100% outside air with zero recirculation. So these are the typical components of outside air damper, which closes off the outside air intake when the system is switched off. The damper can be open spring return with a motor to drive it open. Then it will automatically close the power failure. On many systems there will be a metal mesh screen located with upstream of the filter to prevent birds, small animals from entering and to catch larger item. Mixing chamber, where the return air from the space is mixed with outside ventilation air. Filter, which cleans air by removing solid contaminants. Heating coil, which raises the temperature of air up to the required supply temperature. Cooling coil, which provides cooling and dehumidification. A thermostat must be mounted in the space which will normally control this coil. The single thermostat and controller are often used to control both heating and cooling coil. This method reduces energy waste because it ensures the two coils cannot be on at the same time. Humidifier, which adds moisture and which is usually controlled by humidistat in the space. In addition, a high humidity override humidistat will often be mounted just downstream of the fan to switch the humidification off. Fan is used to draw the conditioned air through the resistance of the system and blow it into the space. So this is the economizer cycle, but we will shift to our main intention, that is, there are four systems of air conditioning system. First one, all air system. Second, air and water system. Third, all water system. And fourth, unitary refrigeration based system. First we will see all air system. All air system provide air conditioning by using tempered flow of air to the spaces. These all air systems need substantial space for ducting the air to each zone. Reheat system. The simplest and least energy system is the constant volume reheat system, and for that purpose we have to assume the main air system provides air that should be cooled enough to. So here we have to assume that the main air system provides air that is cool enough to satisfy all possible cooling loads, and that there is a heater in the duct to each zone. A zone thermostat can then control the heater to maintain the desired zone. So this is the reheat system. So two heater coils are used. The air to each zone passes over a reheat coil before entering the zone. A thermostat in the zone controls the reheat coil. If the zone requires full cooling, then the thermostat will shut off the reheat coil. Then as the cooling load drops, the thermostat will turn the coil to maintain the zone temperature. So this is variable air volume system. This figure shows variable air volume system, which is in which it varies the volume of air supplied to each zone. Variable air volume systems are more energy efficient than a reheat system. Again, we have to assume that the basic system provides air that is cooled enough to satisfy all possible cooling loads. In the zone that require only cooling, the duct to each zone can be fitted with a control damper that can be throttled to reduce airflow to maintain the desired temperature. In both the types, all the air conditioning processes are achieved through the flow of air from a central unit to each zone. Therefore, these are called as all air system. So this is all about today's video lecture. Thank you very much.